Mondays, man, Mondays. Whew. Get used to them. They're 1/7 of your life, pretty much. Get used to it, folks. Wake up. Okay, so what we've got now before we get to our popsicle joke is two different things, real quick. We've got a translated or a center form of a circle that we're going to change into standard form. In other words, we're going to expand this out. Then we've got a standard form equation here that we're going to put back into center form. So we're going to see how to go back and forth between the two. Now, going from center form to standard form is pretty straightforward. It's really just foiling it out or using your specials to multiply these two perfect square trinomials out. So what do we get? If you're using your specials, which I hope you are, x minus 1 squared we would know right away is x squared minus 2x plus 1. And y plus 2 squared would be y squared plus 4y plus 4. And that equals 9. Now, the only thing we've got to do at this point is put it in proper order. And I'll show you what that order is, but it's going to be the x squared term first. If we had an xy term, it would be next, but that's for conics that are rotated. And you'll see that in a whole nother time, not today. So x squared, the next thing would be the y squared, so plus y squared, then the x term minus 2x, the y term plus 4y, and then combine all of your constants together. So we have 1 plus 4 at this point equals 5, but it still equals 9 on the right. To get to the final form, we want it to equal 0. So we're going to have to move that 9 on over here by subtracting it, minus 9, and we get a final answer of x squared plus y squared minus 2x plus 4y minus 4 equals 0. And that right there is what we call our standard form. Okay, so that is standard form. And what is standard form really? Well, standard form should look like this. Standard form is always in the form of ax squared plus bxy, which I told you we don't have that right now, okay? Plus cy squared plus dx plus ey plus f equals 0. So again, remember, you're not going to see that because we're not going to deal with any rotations at this point, but someday, plant the seeds for right now, right? Now, notice this answer here, it's the exact same answer we have over there. So what I'm going to do now is I'm going to show you how to go backwards by completing the square twice at the same time to get to our center form. So let's change on over to a green pen here. And the first thing we're going to do is because we're trying to get to that, right? We're going to isolate the same variables. So I'm going to bring the x squared and the minus 2x together, like so. And then I'm going to group it with a little space there. You'll see why in a minute. And then I'm going to put plus, and I'm going to go ahead and put the y parts together. So I'm going to put y squared plus 4y with a little space in there. You'll see why. Equals, and notice I'm going to move this 4 over by adding it. So I get 4 on the right-hand side now. Now, at this point, what I do is I call it setting up to complete the square. Because what we're trying to do is we're trying to take this and turn it into a perfect square trinomial so that we can then factor it like these, right? That's the idea, is we want to factor it. So I'm going to go ahead and set up to do that factoring already. I know it's going to be an x plus or minus something squared. And then here I'm going to have a y plus or minus something squared. And it's going to equal some number. Now, we got to fill in some blanks here because we're forcing this. We're completing that. We're making it into a perfect square trinomial. So we need to figure out what number goes here to make that. And then once we do, we're going to factor it down to here. We need to do the same thing over here for the y values. And then notice I've left this blank because we're going to have to figure out what the new total is, because when we add things on the left side, we're going to have to compensate over here on the right side for having done that. Okay? So what do we need to do? Well, here's the easiest way to do this. It's a perfect square trinomial. So it's the same thing twice if you remember that from its formula there. But what we've got here is all you got to do is take this number here and take half of it. What's half of negative 2? Forget the x, just the negative 2. Right, negative 1. That goes there. If you now square that number and put it up here, negative 1 squared is positive 1. You've now found the perfect square trinomial and its factor at the same time. Both at the same time. Let's do it again over here for the y values. So what's half of 4? Put it here. Yeah, plus 2. What's that number squared? Put it there. Plus 4. Good. So you've now got the perfect square trinomial here and its factor as well. Now, I did tell you we have to compensate for what we've done. We've done some things here over there that we haven't done here yet. So if we'll get to this another day if there's a number in front, but for right now, this number here we added, so we got to add it here as well. This number here we added, we have to add it also. And finally, let's combine all three of those constants together to get that value. Now, if we rewrite this out to make it look nice and clean, we get x minus 1 squared plus y plus 2 squared equals 9. And guess what? If you notice, there it is right there. We got right back to where we were supposed to. So again, the idea here, going from center to standard form, is just multiply it out. Make it equal 0 and put it in alphabetical and descending order. Over here, the idea is complete the square twice at the same time. And by the way, just to let you know, this is going to be called our center form, as we called it before. And it's in the form of x minus h squared plus y minus k squared. As we talked about in the previous video, it equals the radius squared. So there you go, folks. A little bit of completing the square for your Monday morning wake up. I hope that helped get the brain going. I got my joke for you. What do computers eat for breakfast? Snacks. What do computers eat for snacks? Probably shouldn't have that for breakfast. Right. Microchips. Microchips.